6.5 notes. Conditions for rhombuses, rectangles, and squares. This section is going to be a lot like the previous section, 6.4. So what we're looking for is what makes a rhombus, what makes a rectangle, what makes a square. And then we'll answer a few follow-up questions. So to be a rhombus, first condition, if the diagonals of a parallelogram are perpendicular, then it's a rhombus. I'd like you to go ahead and draw a picture of what this looks like. Should look something like this, where the diagonals are perpendicular as shown by the 90-degree angle in the middle. Next condition, for a rhombus, if one diagonal of a parallelogram bisects a pair of opposite angles, then it's a rhombus. Draw a picture for this. Should look something like this. To be a rectangle, there's one condition. If the diagonals of a parallelogram are congruent, then it's a rectangle. Go ahead and draw that. Should look something like this. To be a square, one condition. In order to prove a parallelogram is a square, you have to prove that it's both a rhombus, so it has 4 congruent sides, and a rectangle, 4 right angles. Remember, there's 2 conditions for a rhombus and there's 1 condition for a rectangle. So you just need one of each to prove it to be a square. Because remember, squares are both rhombuses and rectangles by definition. So take a look at these 2 examples. Can you conclude that the parallelogram is a rhombus, a rectangle, or a square? Explain your answer. Go ahead and pause the video here to answer these 2 questions. Okay, let's see how you did. First one, yes, a diagonal bisects 2 angles, so this is a rhombus. All right. The second one, the diagonals are congruent. We can see that by the markings. And the diagonals are perpendicular. All right, so the first one, the diagonals are congruent, that shows it's a rectangle. Then the diagonals are perpendicular, that shows it's a rhombus. It's both a rhombus and a rectangle, which makes it a square. All right, using properties of special parallelograms. So we're going to use the properties, those properties we talked about for a rhombus, a rectangle, and a square to answer these questions. So for what value of x is parallelogram ABCD a rhombus? Well, what do you think we're going to do with those 2 angle measures? The diagonal of a rhombus should bisect angle B there. So 6x minus 2 equals 4x plus 8. Subtract 4x from both sides. We get 2x minus 2 equals 8. Add 2 to both sides. 2x equals 10, therefore x equals 5. Number 2, for what value of y is parallelogram DEFG a rectangle? Well, if the property for a rectangle, or the condition for it being a rectangle, is that its diagonals are congruent, we can say that 5y plus 3 equals 7y minus 5. We're going to subtract 5y from both sides. Also add 5. I just did 2 steps in one there. We get 8 equals 2y, so y equals 4. All right, let's see how we're doing. Can you conclude that the parallelogram is a rhombus, a rectangle, or a square? Explain. So I'll give you a minute here. I'll go ahead and pause the video, answer these 2 questions, and then we'll see how you did. Okay, let's see how you did. Number 1, yeah, you can conclude that parallelogram STOP is a rectangle because the diagonals are congruent. Number 2, you can conclude that it's a rhombus because the diagonals are perpendicular. All right, number 3 and 4 here. For what value of x is the figure the given special parallelogram? So for number 3, for what value of x is it a rhombus? And for number 4, for what value of x is it a rectangle? Go ahead and pause the video, answer these 2 questions, and then we'll see how you did. Okay, let's see how you did. Here, 3x plus 9 equals 8x minus 1 because all 4 sides of a rhombus have to be congruent, so x equals 2. Number 4, 3x minus 5 equals x plus 1 because diagonals of a rectangle are congruent, therefore x equals 3. Your homework for section 6.5 is on mathxlforschool.com, due Sunday at midnight.